And this n just equal to, or this k is just equal to 0, 1, 2 through the n minus 1. So totally, we let k take all those n integers, and this can cover all those nth roots of this number z. So in this way, we find the formula for the nth root of a given complex number. Actually, you can verify and see if the nth power of this nth root can give you the original complex numbers. Okay, let's take the nth power of this number. So r to n 1 over n times cosine of the 2k pi plus theta over n, and plus I times sine of 2k pi plus theta over n. Then whole thing raised to nth power. So the nth power of r to the 1 over n is just equal to r, right? Then by the de Moivre theorem, we know this guy is equal to n times this argument. So this n and this n cancel. You have the 2k pi plus theta and plus I times sine, same thing, 2k pi plus theta. And we know sine and cosine has 2 pi as period, so you can throw away any multiple of the 2 pi. So you have the r times cosine theta and plus I times sine theta. So just gives you this original complex number. And this verify this is indeed 1nth root of this, okay, complex number. And if you let the k be the 0, 1, 2 through the n minus 1, all those n integers, then you get n different nth roots of this complex number. Any question? Now let's look at one example to see how we find the cube root of a complex number. Let's go to the page 628, problem 24. So we need to find the cube roots of the a times cosine of the 30 degrees plus I times sine 30 degrees. So z is equal to 8 times cosine 30 degrees plus I times sine 30 degrees. Now z is equal to w cubed. So the index here n is equal to 3. We need to find the w, right? So by the formula of the nth roots of this complex number, we know n here is equal to 3. So first we find the cube root of the modulus. So w should be equal to 8 raised to 1/3, right? And then times cosine of the 2k pi, or see the k times the 360 degrees plus theta over 3, right? So let me write this here. Cosine of the k times 360 degrees and plus theta, that is the 30 degrees, and then over 3, and plus I times sine of the k times 360 degrees plus 30 degrees over 3. And here, this k can take 0, 1, and n minus 1. So n here is equal to 3, so the rest is equal to 2. So k takes these 3 integers, and then we get the corresponding 3 cube roots of this complex number. So now let's look at the first cube root, W1. That is the root when k is equal to 0. So you have the cube root of 8, that is equal to 2, and times cosine. Okay, k is equal to 0, you have the 30 degrees here, right, divided by 3, and plus I times sine of the 30 degrees divided by 3. And then you simplify, you get 2 times cosine of the 10 degrees plus I times sine of the 10 degrees. And then we just keep this in this exact form. Now let's look at the second cube root of this complex number. So modulus still equal to 2 and times cosine. And this time k is equal to 1. Okay, so you have the 1 times 360 degrees, 360 degrees, and plus 30 degrees divided by 3, and plus I times sine of 360 degrees plus 30 degrees over 3. Now let's simplify. So 360 degrees divided by 3, you have the 120 degrees. 30 over 3, you have 10. 120 plus 10, you have the 130 degrees. So you have the 2 times cosine of the 130 degrees and plus I times sine of the 130 degrees. And this is the second root. Okay, this first case is when the k is equal to 0, and this is the second cube root when the k is taken to be 1. Now let's look at the third cube root, W3. To have the 2 times cosine of the 2 times 360 degrees plus 30 degrees, then divided by 3, and then plus I times the same argument, and then you simplify. 2 times 360 degrees is equal to 720. 720 plus 30, you have the 750. And 750 divided by 3, you have the 250. So you have the 2 times cosine of the 250 degrees plus I times sine of 250 degrees. And then done. Let's move to the next problem. Page 628, problem 46. And we try to solve this equation, z I times the x squared plus 3 equal to 0. So to solve this equation, we have to isolate this variable term. Okay. So we just move 3 to the right side, then we get I times x squared equal to -3. And then we divide both sides by I. We have the x squared equal to -3 over I. And we need to write this right side in the form a plus bi. So we need to multiply both the numerator and denominator by I in this case. So we know negative 3 over I times I over I. Then you have the negative 3I over I squared. And I squared is equal to negative 1. So you have the 3I. So finally, you have the x squared equal to 3I. So right now we need to find the square roots of the 3I.